Yes, if you can, I'll be happy. Maybe you need to share the screen to allow me to share the screen so I can show you
Absolutely.
some. Yeah,
Here we go.
there we go. Up. And is the big screen on? Is it okay with you?
Yes,
Wonderful. So
perfect.
I'm really very excited. I'm very much looking forward to your feedback because as you've heard from the presentation, I have no formal, no informal training in ethics. And this is more a researcher sharing a voyage, what I'm trying to do as a researcher in chemistry. And to introduce myself, I chose this artistic artifact. You might have recognized Penelope in the middle, that she's weaving on the daytime and unweaving on the nighttime to push further and further the moment when she has to say who she will marry because she hopes to have Ulysses coming back. Why do I relate to this figure? Because I feel I share with her the fact that I'm under pressure to produce results and give answers to important fact, and that I still own some power. She's a queen. I'm a researcher trying to contribute to with my research to one of the crises that we're going through. And to go into a little more detail, this is a presentation of one of my latest paper where the red parts, we're all chemists, we understand that these are atoms, where the red parts are photosensitizers, where the blue parts are actually photocatalysts for oxygen, for water oxidation, and the yellow tails are what I added with my team to a system that was developed by Marcella Bonchio in Padova, the blue and red one. And with my team, we put the green part so that we could make a stable material. And to explain this to a general public, I try to say that we make material like these little plants that can turn light and water and into an electric current and into energy. So this is a very suggestive way to say that I'm working on the energy transition. And at the same time, it's a way of showing that we do things and we make decisions and we try to answer to this urgency. But like Penelope, I have also a side that is maybe less standard, or at least less present in my CV, which is to think and to push back the necessity to answer the question in a way that I'm expected to. And to materialize that, we have recently published a paper. And when I say we, it's about 20 people, chemists mostly, but also geographer, historian, philosopher. And I will let you know more about how we created this collective, how we decided to use non-violent methods to actually select a way of thinking. And our starting idea was, how does knowing the context of the Anthropocene, as chemists, we can understand how the limits in planetary boundary reflects on the research that we're asked to do. To give you more information on the rest of the talk, I will focus only on the second part. I will tell you how this work has led me to an assessment that elicits ethical questions. And in the second part of the talk, which is more about situated chemistry proposal, how I react and what is the proposal following this assessment. So let's look at the assessment. The starting idea was to actually take a sustainability framework the framework that you know, developed by Rockstrom and Will Steffen and Crutzen, Stockholm Resilience Institute now, where there are 9 planetary boundaries and explicit quantitative indicators that allow us to evaluate whether we are within the green, safe operating space for the system Earth or beyond this safe operating space with increasing risk. And you see that many of these boundaries have been trespassed, and this is a worrisome moment. So one, we use the sustainability framework to analyze the position of 5 chemical entities at the energy chemistry nexus. And we have chosen CO2 for obvious reasons and climate change, methane as a representative of fossil fuels, hydrogen as an important vector of energy, ammonia, which is morphing from a nutrition intensive molecule, intensive in the sense that it's really important, to an energy intensive molecule, and biopolymers to give us a handle about the material facts of plastics, for example, and other material. So one sustainability framework, 5 chemical entities, and 5 research policy orienting scenarios. In particular, the IPCC, DECIMA, Shell, International Energy Agency, and Sonergy, which is a mostly European group of researchers informing and giving their ideas to the European Union about how the energy transition should be. So we tried to bring these 3 aspects together. Through each chemical entity, what is the dominant projected future from the conjunction of these 5 scenarios, and how does it reflect within the planetary boundaries framework? And to analyze them, to make a discussion, we chose 6 interdisciplinary examples: energy transition history, ammonia Earth system, methane and hydrogen and political science, plastics and decolonial studies, access to natural resources and cultural studies, and CO2 and game theory. Just to give you an idea about a flavor about what we wrote, for example, and what we find inspirational in the literature is this theory and this position by Jean-Baptiste Fressoz, who is a French historian, and he's very much contesting the idea through the experience that history gives that we're actually going through a transition. What he's trying to say is that more than a transition, we have had a stacking of different energy sources, and we're still on that dynamics. The other concept that we find really inspiring is about the material symbiosis, about the fact that there is no loss of use of a primary source over time, but there are some material symbiosis. And this picture very well, in my opinion, shows it. This is a tunnel in a coal mine. And I quote an excerpt. In some historical analysis, this is Jean-Baptiste Fressoz speaking, wood was said to no longer play any role in the British energy mix by the middle of the 19th century. Then there are, as a good historian, there are sources among which Smill, there are archives, but his conclusion and his data is yet by 1913, Great Britain used far more wood, as you see, to actually stack and to actually upheld the coal system. So it used far more wood to extract its coal than it had burned it in the middle of the 18th century. So even if we didn't burn wood anymore to energy, we use more wood to allow the new energy. So this idea of symbiosis is something that might also need to be taken into consideration when we talk about lithium, when we talk about all these forward-thinking new solution, and think about how it connects to aluminium, how it connects to copper, how it's anyway. So this is one way of putting in perspective the dominant future of research that some of the scenarios we're exposed as researchers show us. Not only historians can inspire chemists like me, but I think chemists also can have a distinct input on understanding what is shaping. And the example that best shows this is our analysis of the Haber-Bosch system. So you're chemists, I don't need to explain you that Haber-Bosch is the process that is so important about transforming air, nitrogen into ammonia, and ammonia also through oxidation to nitrates and ammonium and urea can go to fertilizers, which then allow to go to food. As you also know, ammonia synthesis is among the largest, if not the first largest chemical because of its use in fertilizer. It was 150 million ton in 2013, and it is now almost at 200 million tons. And I don't know if it's hidden by the bar, but you might see that on top of the N2 plus 3H2, there is something highlighted in yellow, which is actually the real stoichiometry of the Haber-Bosch. If you take into consideration that in the best case scenario, what we have is hydrogen doesn't just run around in the planet. We need to make it, and we make it from fossil, and in the best case it's the steam. So on top of the 1.8 CO2 emitted per ammonia produced that are just stoichiometric, we also have to add the process energy that is required by the Haber-Bosch. And even if the experimental condition of 100 atmosphere and 300 degrees seem to be very high, it's actually one of the most efficient industrial process out there, where the thermodynamic limit, called the exergy limit of the best case scenario, is very close. And that's what I'm trying to say here. The best Haber-Bosch process out here are very close to the thermodynamic limit. And this picture was taken from the IPCC exercise of 2003 that was pointing at ammonia as a necessary service to provide fertilizer, and at the same time a process that was consuming about 1.1% of the overall energy used in anthropogenic activity, and emitting the same share of CO2, and that we couldn't hope much more about improving efficiency because we're really very far off. So one of the suggested idea was to actually, rather than using fossil hydrogen, to use green hydrogen, which was called green or carbon neutral or defossilized. I'm moving forward in time from 2007, and from this green idea is emerging a whole rainbow of carbon neutral hydrogens that are being considered as interesting carbon neutral energy sources. And the Haber-Bosch is being considered both as a vector of this non-fossil hydrogen, which in the scenarios that you see over here in the middle of the screen, this is a scenario taken from the EIA, International Energy Agency, and you see that on top of light blue and dark blue, which are related to nutrition, non-fertilizer use, which in grand part is explosive, you see new utilization popping up. In dark green is maritime fuel, oxidized directly into a big tank to release power, and in yellow as a power generation which could mean as a hydrogen vector. So you see how the idea of using a system that is very important because it gives fertilizers and therefore food and uses 1% of energy that we need to go to carbon neutral, the machine is actually getting more and more energy. And if you look at the IPCC reports now, ammonia as a fertilizer is barely mentioned. We should have precision agriculture, et cetera, but mostly it comes out as an energy use, and the volume is getting bigger and bigger. But this analysis, which is completely correct in terms of chemical engineering and the level of the infrastructure that already has been deployed, needs, in my eyes at least, and misses in what I read, an enlargement of the effect of the Haber-Bosch process now. First thing first to me is that we hear still very recently, Haber-Bosch cannot be touched almost because it feeds half of the world. Does it? First thing, and I cannot help, I don't need it to go into the energy, but I need to say it because it's a good example to show how this global planet scale averages have something profoundly unjust embedded in them. When we say that Haber-Bosch feeds after the world, we're actually correct in average. But if we go to the hunger map of the FAO 2020, and I haven't written it here, maybe I should have put it, you see that there is a clear north-south line between what countries in average eat enough and what country in average don't have enough food. So blanket statements like this, feeds half of the world, lead to the desire and the need to actually say which half. Do you realize how situated and point of view is presented? The second thing is that we forget about Haber-Bosch feeds half of the world. Haber-Bosch is extremely efficient to make ammonia. But if we say that Haber-Bosch feeds, then we have to look at the efficiency of turning ammonia into food. And these are the numbers. 6% of the ammonia that is being produced in a mega plant is lost before applying fertilizer. 47% do not go to the crop. 16% are not harvested. 10% is lost in this material balance when we have several loops within the food chain. We have an animal that breeds grass that has been fed, and et cetera, et cetera. So this is how we lose this further 10. 5 and 12% don't go to are not eaten. They're lost before harvest, or they don't go to a plate. So the bottom line is that the Haber-Bosch efficiency to food oscillates between 4 and 14%. This number, to me, is an eye-opener. And is an eye-opener because while we concentrate through all these scenarios of a carbon neutral transition to fixing the CO2 that is being released between nitrogen and ammonia, and I've showed you how much this has fed the idea of green hydrogen and transition and more ammonia, we are completely forgetting, at least it seems to me, that there's 90% of runoff reactive nitrogen impacts. So we don't look at the consequences from an ecological point of view. I will just mention one. Out of the 200 million ton of ammonia produced, we want to fix 300 million ton of CO2 from upstream steam Haber-Bosch. But 3 to 4% of the runoffs of reactive nitrogens are under the form of N2O. If you make the calculations of N2O, is 8 million ton a year are released. In terms of greenhouse gas equivalent, N2O is 300 times more potent than CO2, which means that if you, again, you do all the numbers, you have 2,300 million tons of CO2 equivalent downstream only for N2O. And all the discussion has been justified for trying to fix this thing. And I'm only talking about N2O. I'm not talking about the fact that the ocean at the end of the Mississippi, so in the Mexican Gulf, are in complete anoxia because combination of nitrogen and phosphate from the Mississippi agricultural runoff combined with the temperature of the summer leads to anoxia over the ocean. I'm not talking about the fact that gaseous nitrogen oxide are responsible for many atmospheric pollution. I'm not the most competent, but also sheer ammonia is the base that is most of the time the base of the PM 2.5, the particulate matter 2.5. We know that there are a lot of acidic oxides, but you need a base to make a salt, which is what PM 2.5 is, and this base is ammonia, with all the consequences of PM 2.5. So the juxtaposition between the desire tomorrow that the research scenarios are suggesting to us about work onto green ammonia with what is happening today, and it's actually, in my reading, in one of the blind spots of all these hegemonic scenarios, is a call to reflection. This is the story I wanted to tell you about our analysis of ammonia and Earth system analysis. As I told you, there are many more, and it's a big paper, and we were happy to see that Chemical Science chose it as an Edge article, and we had a cover feature. And these are our conclusion. On the scientific method, the technical uncertainty is compounded by risk linked to environmental, geopolitical, and social effects, even when technology were to be technically available at scale. And this risk are seldom put forward. In all the scenarios we have chosen, but that also the ones that we feel are the ones that are orienting our research calls, for example, for funding, they are invariant between present time and projected transition. And in all of them, there is the hierarchy of values that it has to make sense from a business point of view. Sustainable development as 3 bottom line in some definitions. It has to be economically viable, ecologically sustainable, and socially just. But there is one which is never forgotten, and it's the first one. And that one is present in the past, is present now, and will be present in the future of these scenarios. And then third is that in order to build and justify our scientific choices, we rely on cultural axioms that are mostly not questioned nor explicitly mentioned. To explicit this one of our conclusions is the need to open to transdisciplinarity. The second conclusion, line of conclusion is about the time frame. A revisited analysis of the Club of Rome update on the scenarios, you guys are all aware of this, I don't need to go into it, but basically what it's telling us is that the least likely scenario among the several ones that Meadows and team from the MIT proposed now 50 years ago, the least probable one, given the experimental data up to 2020, is the stabilize the world, which is scary. Which means that the safest scenario that has led to the Brundtland definition of sustainable development, that has nourished so much of the reflection about where should we go, is the least probable. So the urgency is evident. We need to avoid not to change. We need to avoid the risk associated with implementing some of the aspects of the dominant scenarios discussed, the call for scalability, I give some detail, and it's therefore urgent to slow down, not to find solution, but to question the solution that we're so massively following. So we probably need to edge our bets. And here I'm coming closer to this idea of ethics, is that broader scenarios are needed. Our suggestion is that we have to look for other economical, social, and political framings, like post-growth theories or ecological economies or decolonial studies that could be inspiring, and that we have reason to believe that not only they're inspiring, but they're probably also political reasons that explain why they have become minoritary and why it is also political work to reactivate them. The end is that this mismatch between what we're invited to do in some cases and our analysis of the same data that does not come to the same conclusion reactivates to the need to align with our own values. And it's funny, this is one of the reasons also we connected with Hans, is that the final quote of this paper that was really important, and we have it as a box at the end of chemical science, is a sentence by Roald Hoffmann, which, if I understand correctly, is a member, honorary member of your group. So we quote him: "I believe that scientists have absolute responsibility for thinking about the use of their creation and even the abuse by others. So we need to reclaim a capacity to see the effect of what we do all the way to the applications." So this ends the first part of my talk, and it ends it with a sentence that I'm sure you know well, which was said by Andrew Refkin, quoted by Joseph Stramberg, and for us closer by Peter Mahaffey in JChem Education 2014, Telling Time, Chemistry Education in the Anthropocene Epoch. And the quote is the following: "Consider this: 2 billion years ago, cyanobacteria oxygenated the atmosphere and powerfully disrupted life on Earth. But they didn't know it. We're the first species that's become a planet-scale influence and is aware of that reality." So this is, with this point, I would like to switch to what I'm trying to make out of this invitation. And the rest of the talk, which is about 15 minutes, is is very homemade, and this is what this boat wants to show. You know, we're going on uncharted territory. We don't really know more or less where the destination is. If it were me, I would have added some fog in the picture, but I saw in the Sail magazine that you can actually build your own boats. So what I want to convey is that I have the desire and probably the need to find a way of framing my research that is satisfactory with respect to my values and my desire. So to introduce it, I'm quoting Anderson, the Nobel Prize in Physics winner, that says, "More is different, broken symmetry, and the nature of hierarchical structure of science." This is Paul Anastas that made me aware of this paper, and it reiterates the way that there is a necessity to bring together different sciences to address questions that are necessary to own the relationship between what we do, me in green chemistry and many others, obviously, all the way to the society, which, how Roald was saying, we're responsible for the use and the misuse. And if we're responsible, we need to be able to at least have a faint idea toward what are the possible things that will come out of our research. To give you a personal example about how we are unable, in great part, to address question. I'll give you this, that was a discussion that we had in the Green Chemistry Board. We received a paper in 2015 when Walter Leitner was the chair. We received this paper, which is stimuli responsibly over here. Stimuli responsible reversible hydraulic fracturing fluids as a greener alternative to support geothermal and fossil energy production. So basically, this is a greener synthesis of surfactant for fracking. And the question we had to discuss in the board, and that Walter said, is like, okay, we all agree that eventually we have to move away from fossil fuels. This surfactant is greener, the chemistry is fine, and we can send it to reviewer and will make sense that it's excellent. But should we have fracking within the journal? And what was interesting was the discussion about how polarized it was inside the board. Some of us were saying, no, we have to defossilize. We have to look at the future. We're not about helping fossil industry. And also in the same board, some of us were saying there is more chance that we will do good and reduce CO2 emission by helping this kind of work that have direct industrial application than waiting for some photo, blah, blah, things like the ones that I'm doing in opening that will have an effect, if any, in X decades. The conclusion was that we didn't know. And Walter wrote an editorial, which was the subject of fracking in green chemistry. And the sentence he chose was in dubio pro reo. We don't know how to answer this question. And therefore, since we don't know, we should give a chance. And the paper got published. So this to me seems to reactivate a sentence by Edmund Husserl that wrote The Crisis of European Sciences and Transcendental Phenomenology in 1936, which, anyways, I have that says that progress came at the cost of losing sight of the unity of science and neglecting essential questions concerning the meaning and purpose of the whole of human life. Even if this is very overpowering, there is the idea that too much disciplinary specialization is making us very efficient in that discipline, but unable to connect all through the connection of science. Okay, we're not going to go there, but like Auguste Comte, without taking the positivism, but from mathematics all the way to sociology, going through biology. And it's this unity that we don't have tools for. So how do I continue? I continue with the idea that we need help from outside. We already have LCA and toxicology and physics and business and law, but we need other disciplines. And I'm proposing one specific concept developed in social science. But let me get there. We need help from outside and maybe more than what we fear. What do I mean by that? To explain why there are reasons to believe that our method of scientific assessment and self-correction might not be adapted to the speed at which the world is changing in this Anthropocene epoch. I'll show you this political psychology paper published in 2015 by Dan Kahan. And again, it's Paul Anastas. I really acknowledge how much is nourishing and inspiring to me. So he showed me this paper. On the x-axis, you have what is called ordinary science intelligence. So basically, the people that are polled, they have to say, do you know the formula of water? Do you know what gravity is? Do you know blah, 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 blah? And depending on your answer, the person that responds goes from low, let's say, scientific capital to very high scientific capital. We all will be about here. Then to these people that were polled, the person asked a question that is over here and that I will summarize in, do you think that there is a global warming due to fossil fuel burning? Yes, you answer here. No, you answer here. And you seem to notice a slight correlation between the more you have scientific capital, the more you, quote unquote, believe in anthropic, in climate change of anthropic nature. This is a paper of 2014, 15 in US, and so it's things might and probably have changed since then. But back then, the original thing to me that Dan Cahan did is he also asked to each of the people responding to self-identify in political groups. And when you inject that information in this data, this is what happens. I'm playing coy here. I'm hiding who is political group A and political group B, but if you go to the paper, you will see that one is Republican conservative and the other one is liberal Democrat. But it's not really about who is blue and who is red. It's about the fact that the way you answer to a scientifically intense question that needs a lot of scientific capital becomes more and more different depending on your political identity, the more you have scientific knowledge and not the less. So basically, the more you have ordinary science intelligence and capital of scientific, the more who you are within yourself orients the way you interpret experimental data or the data around you. And this is why I'm saying that maybe we need help from the outside even more than what we fear. Because rather than protecting us and being fact-informed, there is a period in our production of science where it's the reverse, where who we are influences the interpretation of data. And the reason why I say that I fear it is that with the acceleration of changes, of global changes, of crisis and everything, the mechanism that we have inherited in modern science of the 18th and 19th century of a community that knows how to correct when there is a controversy, we continue, and eventually we solve it. How do we have the time to have this mechanism active when the Anthropocene is also an accelerocene, where the changes are accelerating? So by the time we have come to a conclusion, the world has moved already and our science objective have moved, etc., etc. So this is where I think and I hope I have a hope that actually we can use this to improve the quality of science from an epistemology point of view and from a political point of view. Because by disentangling knowledge from identity, we can strengthen the transformative power of both. And one way to put this forward is applying, at least that's what it evokes to me, the biologist, philosopher, and feminist Donna Haraway that wrote the paper in Feminist Studies 1988, Situated Knowledge, the Science Question in Feminism and the Privilege of Partial Perspective. Just to give you a little background, 70s, 80s, very, for me, correct and strong criticism of the scientific arena as an arena that was filled with sexist and patriarchal domination. Some feminists said science is just not a place we want to be. It is just doomed. And Haraway with others said, no, science is a place we have to stay in because the methods are interesting, the knowledge is important, but we have to enlarge the point of view from which science is produced. The problem is not science enough; it's the narrowness of the perspective that have the right to be considered from within. So to quote Wikipedia, that is the clearest sentence that I have found. She Haraway posits that by acknowledging and understanding the contingency of their position in the world, and hence contestable aspects of their claim to neutral knowledge, subjects can produce knowledge with greater objectivity than if they claim to be detached observer. So better science and more diverse science, the two go together. This is my example of how to show that we are embedded in this lack of situatedness. You know about peak shaving strategy is if over time you have a request that exceeds the power, the possibility is to go into later in time and find a way to respond to the request. And this is the example I want to give you about ignoring the situatedness of its perspective. And this is my real life experience in a conference. There was a great professor that actually was explaining how his battery, and in particular his membrane, that was a little costly, but was completely deployable, because you could charge the battery at night and then sell the electricity that was stored in the battery during the day. So this was peak shaving and shifting strategies that justified the interest and of that research. What was a little there is a word for this. What was a little not reading the room, but was that I showed this conference, I heard this conference, I was in the public in one of the countries that is in dark purple. And this map here is electricity access. So there is nothing wrong in the solution that is being proposed, and it makes a lot of sense. But it makes no sense in a country where the access to electricity is 4%, or it makes sense for those 4% that have access. So the idea is that ignoring the situatedness of our perspective is still a situated knowledge, but is a situated knowledge that caters to the interests of those who profits of this non-explicitation, and creates injustice toward those or the system that are outside. That's why I consider that it's both epistemology and justice. So, and here is, I tie back to the idea of universality, is that notwithstanding the universality of the proposed framework would tend to suggest we need to fight against global warming, therefore I will make a battery that works on photo, whatever. This type of research is part of a specific framework responding to a problem that is relevant to a subset of people, those who have access to electricity. It is not a universal solution to a universal problem. So there's nothing wrong with this research. It's good. The topic is good. It is green chemistry. Global warming needs to be fought. And at the same time, the universality of the backdrop omits the specificity of the solution. So there is a loss of universality somewhere within the argument, and this it's better science and it's wider sciences if we explicit it. So I'm coming to the proposal itself. The proposal itself is called, as I told you, Situated Green Chemistries with an S. And here is the idea, is that if you read sociology and philosophy and other things that I've tried to dabble in about situated, it's very complicated to understand what does it mean to situate oneself. Do you situate yourself? Do you situate someone else? Is it your history? Are your choices? It comes very close sometimes when it's mishandled to putting people in boxes and assuming that because they were born or raised or exposed to that box, we already know what they will do. And this is obviously a place not to go. But I thought there was a way of understanding and evoking this situatedness that could be interesting. And I was inspired by this work of this historian. Her name is Anne-Françoise Garçon, and she studied electric cars. And in Paris in the early 20th century, two types of car coexisted, electricity and gasoline. over time in Paris, electricity, city cars were lost the competition, and there was only gasoline. So basically, she explained it because there were technology and research problems. There were problems of cost, so economy. There were problems with the centralized network, so societal organization. No technology exists in the vacuum. I'm sure I don't have to say this explicitly here. But more fundamentally, she says, the automobile was gradually invested with an imaginary of its own. People started daydreaming about going outside of Paris. People started enjoying race cars with gasoline. And this idea of the shared narrative was an important point in allowing this shift. And this is where I would like to focus the idea of situated green chemistry, is to explicit the driver, explicit the shared narrative toward the future that we want to contribute to. That's what I was saying about disentangling identity from research to increase the transformative power of both. If you can align your driver and somewhere your values and your shared narrative with the topic of your research, and there is a context that allows you to do that, probably you will feel better and you will be in agreement with your ethical and values and things like this, but also you will do better science. And so one of them is what I call force of nature. So, for example, believing that the best thing you can do is to, like we saw the surfactants, improve fracking, because that is concrete and that will make an effect. So that's absolutely one driver, and we have plenty of examples of it. I might even say that probably these examples are hegemonic, but there are other out there. Let me show you one example, one about social justice and north-south imbalances. This paper came out in Desalinization in 2021. And the question was, is lithium brine water? Basically, this author used Monte Carlo simulation method to study the mobility of lithium ion in very concentrated brines. And they compared their simulation with mobility of lithium in concentrated water solution and in solids of anodes and electrodes. Why is this, to me, a social justice problem? Because in the introduction of their paper, they said concerns around brine extraction at the Atacama in Chile, where there is extraction for the energy transition in Europe, could irreversibly damage the basin's hydrological system. Lithium industry stakeholders have historically described brine as a mineral. Others, and in particular Mapuche people living around it, say that it's also a type of brine and of water, and that's why it's in connection with the hydrological. So here we show blah, 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 blah. We use our chemistry to address this question of also social justice interest. And another example is, we know about this, citizen science in action to assess critical air quality and then go and lobby towards some new laws or other. That's also a possibility of application of science. Let me give you another example. Researchers like this community of engineers in Toulouse that are very much inspired by Ivan Illich, who is known as a degrowth thinkers, and they believe that we need to degrow and blah, 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 blah. But we will still need to have the capacity to do some metallurgy, because even if very little, we will still need iron tools. But how to do it in agreement with their perspective of conviviality, rather than using the current method, they're using solar concentrated and hydrazine and ammonia as reducing agents. So that is new chemistry, that is new science, and it's explicitly situated in a vision for the future. people that could be, I'm not one of them, I'm completely freaked out by this idea, but people that say, you know what, maybe we're going to go to a dystopic 5 degree, 6 degree, 7 degree increase locally, disruption of drugs. How do I give insulin to my neighbor if I'm in that situation? I want to be the kind of scientist that does that. So there is an open insulin project that shows how to make it in a garage, and that has been published in Biotechnology. And so this is the way: cure and repair, the power of art, do no harm. For example, exposome. I heard someone here, I think, mention this idea. And finally, also, the idea of epistemicide could be an interesting a way to curb the north-south injustices. I'm going a little fast, but it's just to give you a flavor about what this situated green chemistry is. We start with the driver, and we retrosynthetically find research axes that align us with our values. And if we're going to do more robust chemistry, more diverse chemistry, probably larger. And in this context of ecological crisis, it's a way of hedging our bets. Please make the most dominant way of doing research succeed, because what we want is success. But maybe it would be smart also to try other ways and letting place within our community for that. So my conclusion is in 3 theses. World is changing very or terribly fast, and science and research has to change in some of its foundational aspects, particularly overcome disciplinary isolation. The second thesis is that research, especially for sustainability, needs reflexivity. You know about this. Some places where I showed us are not aware. So it's the act of examining one's own assumption, belief, and judgment systems, and thinking carefully about how this influence our research process. So that's number 2. Broaden the cultural habits embedded in our research to hedge our bets. I'm by tradition an altermondialist politically, which means that I believe that other worlds are possible. It's not about saying who is right or is wrong, but it's about enlarging inclusion and diversity. And the third thesis, and the one that I'm trying to defend, is that we can do that by expliciting the situatedness of a scientific assessment, being inspired by Donna Haraway. So this is my last talk. This is the people with whom I do my daytime Penelope work, and I very much acknowledge them, and I appreciate very much working with them. This is the people with whom we think and we have this reflexivity. Most of them were at this summer school on interdisciplinarity, and that's with them that I wrote the paper on the chemical science. And the latest of my colleagues are Patrick Desgeorges, a philosopher, Samir Barmediene, an historian, and Alexandre Regal, a sociologist, with whom we animated an ethics moment during the International Congress on Catalysis that was about in the context of Anthropocene, how can we uncouple the development of catalysis, the science of acceleration of the transformation of matter, from the worrisome aspects of the ecological and socio-environmental accelerating changes? And this also connection between Anthropocene, catalysis, and Accelerocene is very nourishing. And finally, my lab, IRCELYON, who is considering to have an institutionalized mission interdisciplinaire about this kind of approach. And you for your kind attention. Thank you.
Thank you very much. This was great. Great stuff.
Thank
Truly,
you. Wonderful.
truly inspiring.
Unbelievable. You opened a few new windows for us.
So let's
amazing.
open the floor to questions. Thank you very much.
Wonderful. Some intellectuals among us.
Olympia, what question do you have?
Do you hear me?
Yes,
Yes.
I do.
Yes, I wanted to say it's incredible if we are a little bit more open-minded, but no one taught us this. Let's be honest. I mean, we are reading a lot of literature in chemistry. I know I'm in activity. I have to do that. I have to be competitive to bring money. Do you hear me?
Yes.
Yes. Yeah. We have to be competitive to bring money to earn projects and to have PhD students and so on. And I am a person, I like very much to read also something else, but sometimes I completely agree with Alexandra. I mean, I feel that we are very narrow-minded. I feel that we have not enough knowledge.
Yeah.
But how we can do that practically, Alexandra? I need also to money for my people for the lab. I would like really to read a lot of books. What you recommended, I will do it. But how we can do that practically? You know, we have to put us. I mean, you showed this catalytic conference, and you have shown that you had a part with this. And I think, yeah, this would be a way to make such things in the conferences, not only to see the very specific small point, but to see the whole picture. And I think we went in the wrong direction. And one philosopher said once, we will be so specific in our knowledge that we'll know everything about nothing.
Yeah.
Thank you.
Yeah.
Thank you,
I
Olympia.
mean, Olympia, fully agree with you, but perhaps we are not courageous enough like Alessandra.
So, Alessandra, what do you say to the question? How are we going to do it practically?
Well, first thing that I have to say is that time is the essence of the game. And the fact that we do not have time to think anymore is part of the way that we are dominated. And we have to acknowledge that. At least it was helpful to me when someone said that, you know, it's not only Charlie Chaplin on Modern Times that doesn't have time. The way the time is accelerating for you producing is a way that you're dominated, and you have to emancipate yourself from that, and you have to acknowledge that that is a pressure that you feel. And so I can tell you about my fact, how I went through this. 2 is that we are a community, which means that we don't have to do everything, all of us, and in the same ways. And the fact that some of us can dedicate more time and some of us can dedicate less time, it's all okay. We shouldn't feel that kind of pressure. It was insightful to me to read one paper, and I can maybe put it in the chat over here, which is Strength, Stamina, and Structural Violence in Social Sciences. And again, it's written by 2 female workers who are saying about the fact that the privilege of time is a privilege that we don't have all the same. We don't have with respect of our bodies. We don't have with respect of our family engagement. We don't. So privilege of time is something that some of us have and some of us don't. So my solution for trying to liberate time is to actually learn to say no to some things. And I don't know how to say it less. It's we're invited. It's to have more and more students, to have more and more projects, to have more and more responsibility. But I think that's part of the domination. And depending on your privilege of time and depending on your situation, there's maybe something that we can create. And what is also working for me is the fact that I'm connecting it directly to my job. it is not about the good or this should be. It's a necessity to do well my job. So if I can articulate it like this, I think I can justify it within my employer. And then there was one more thing about this my job that will come. You know, that's why the ICC came out. If I do something within a conference community, but rather than presenting a paper on my photocatalyst, I do an animation on why disciplinary is there is a problem, I think it's gonna fly, and it works both ways. So we don't have the same privilege of time, but finding time is also part of the struggle.
Thank you.
Okay, thank you very much.
Luigi, there's a question from your side.
Yes, just in one of the conclusions of Alessandra, she spoke about transdisciplinarity.
Mm-hmm.
That is a very important word, really. But one slide after, she makes a call to chemists.
Mm-hmm.
So my question is, our university and also research institute like CNR, Italian or French, are articled into departments, and the departments are generally based on disciplines. So my question is, where to get this transdisciplinarity that is needed in order to jump forward?
I can tell you what I see from CNRS is that there are some specific projects that have this layer, and if you're doing something out of the box, you're by definition in the periphery. So to hope to have a centralized, organized structure when you're at the periphery is probably not likely. But, and that's something I could have said already at Olympia, I believe we are in a historical phase where we were not even 5 or 10 years ago. The fact that dams are, we have been flooded in France very strongly, and my dad is being flooded in Italy, and we have had 50-degree heat. And I mean, I don't have to get too much pathos, but we are in a moment where everybody's feeling that something is going on and that we need to pay a lot of attention, and that maybe it's not going in the right direction. So there is an attention to things that are out of the box that was not present before. My way of justifying from within chemistry is, as I tried to tell you with ammonia, is I can use chemistry-related points. I don't have to, I can tell you that historians and geographers are necessary to do my job as chemist.
Yes.
Not to become a new scientist. So I think I can make a case about being chemists, owning the responsibility in a historical moment that is very particular and could be worrisome. So how can I be a chemist that, like Roald Hoffman, understands use and misuse? And this is something that can be heard. But Luigi, don't be surprised about the fact that disciplines, science is organized in discipline. It's a struggle within modern science that spans over 200 years.
Yeah.
The fact that Husserl had to remind us about unity of science. The fact that Auguste Comte had to remind us about unity of science. The fact that Diderot had to remind us of the unity of science is that there is a tendency to separate, and there are other people like us who want to keep them together, and it's part of science. And anyways, that's
Thank you.
Yeah. Very good. Thank you, Alessandra. Perfect, your explanation. I agree, and I think that this reference to unity of science at the end is very important because it's a final point of arrival.
Thank you, Luigi. Yes, that's it. Anka has got a question, and then Hartmut.
Yeah, it's So thank you, Alessandra. Of course, as already Hartmut said, you open a lot of things to be further discussed in our group. In fact, this was also my first impression. Maybe the conclusion is, yes, we need inter and multidisciplinarity. We need good scientists in all sciences. But how can you see the future as nowadays we see the people are, and I'm thinking not to very well educated scientists, to excellent scientists. I'm thinking to the normal people because it's a problem all the people should know and should put in practice, in fact. But nowadays we can see that at least the young generation are less and less sociable. They are discussing less and less each to the other. All stay with the phone, with Facebook, with internet, looking and being concentrated on their own interests. What do you think? How will be developed the science? How will be developed the relation between all the sciences and all the things which are important for our life? Because also nowadays, a very simple example, somebody is suffering, I don't know for how many illnesses, has some symptoms, is going to a specialist in a narrow area, let's say to the cardiologist, but has also other problems. A specialist is treating normally and generally only his own specialty. Is not, there are very, very few specialists in the whole world which maybe are open-minded and they can think to all the problems and can put all the things together. In fact, this is a problem. And who is or how we can develop ourselves, the young generation, to think in terms of putting all sciences together.
Yeah. Thank you.
Thank you.
Clear. Thank you.
Yeah, I'm not comfortable talking about what other people should be doing. I really feel that I want to test this within myself and the group and within our community and as intellectuals, because that's what we are. We're paid to think, actually, more than to make materials and other things. And I think that's what we can try to make these experiences. And as you say, it's about complexity and system, and there are system thinkers now, and there are new courses, and I'm sure that in your ethics you're touching about many things. So I might not be as pessimistic about the young generation. With the few things on interdisciplinarity that I've seen, I found a lot of support among our PhD students, and maybe more than among some of the colleagues. And that's what I wanted to tell you also, Olympia, about what you said. We are dominated on time, but we also dominate other people's time when we are in our generation. So that is a power that we have that we can also unleash. Maybe you and me were doomed in writing reports and all we have, but we're also PhD supervisors. So to allow a PhD supervisor to have half a day a week to think about this and to find something in the group and to consider this part of our job and not one less paper and one less thing, that's one. The second thing is that we also hire people and we recommend people and we evaluate and we're in committees to understand what are the criteria within our practicing that are continuing this domination over time is interesting. For example, asking someone to tell us about everything that person has done since the end of the master or even before to now is not equivalent as asking, what are the 3 most significant things that you've done? And why have you done it? How have you contributed, etc., etc. So poking holes into this domination of times in our schedule and in other people's schedule while maintaining excellence and relevance to our job is also an avenue that we have.
Yes. Thank you.
Thank you. Yes.
Great answer. Thank you. Hartmut, you've got a question.
Yeah. Alessandra, a terrific lecture. It's unbelievable. You opened so many thoughts. I liked your the mentioning of the situated green chemistries, and it suddenly became clear to me there is not one green chemistry which we have to define and then put into cases and boxes, but the green chemistry I was struggling years ago about. I mean, I wrote a paper on the fairness of chemistry worldwide, and now I find, yes, you're right, we have to adapt the green chemistries we are thinking about to the sociological and geographic and so on conditions under which the people live. This is unbelievable. I mean, I'm very grateful to you. Now, and the next question is, maybe artificial intelligence would help us to overcome this dilemma. What do you think?
One of the, I don't know, did I send you the posters that we have done for the ICC?
No.
Did you receive a copy? I can send it to you and share it with you. 3 of them is about overcoming disciplinary isolation, written with a philosopher. So it addresses some of the things we said. One of them is about my situated chemistry. The other one is chemical science. But one of them, and is about fairness in machine learning from the perspective of sociology. And reading it is they found these are people doing reflexive into machine learning, knowing that fairness and ethics is very strong. The code that they write decides if you go to prison or not, or if you have a loan from a bank or things like this. If there are biases in recognition, there's going to be injustice. So the connection is very direct. So there are 3 biases: pre-existing bias, from previously involved. If your data are wrong you're going to carry out that in the internal artificial intelligence. So that is something we have to cope with. The second one, and that is to me the most inspiring, is what is called the technical bias, that stems from quantifying the qualitative, discretizing the continuous, and formalizing the abstract, the informal.
Yeah, quantitative is qualificative.
This is a bias which is enshrined in this method. I'm not saying it's wrong. I'm saying it has bias we have to cope with. So again, more power to you, and I hope you succeed, because that's all the energy that it's in. But I for sure know that I don't want everything to be IA because there are biases. And the third one that also resonates with Anthropocene is emerging bias. It's that when the software system interacts with the changing world, the fact that you do something like, and then the world has changed, and then how does it adapt?
And then you extrapolate from one situation to another one, which is then already incorrect.
So that's so there's no way you can stop a sliding snow. So I hope it plows a path to sustainability, but I know for sure that I wish we can edge our bets in producing knowledge there too.
Thank you very much.
I'd like to ask a question myself. You alluded to it, and I had a lot of thoughts, a castle of thoughts connected to it. when you talked about situated knowledge, in my context, when I work with businesses, I more and more stress the fact of the so-called social organism. And the social organism is something I cannot elaborate here, but it enables people from all walks of life, whether they are educated or not educated, to train themselves in judgment formation, even in areas where they are not experts. And, it counters what Anka has said, alienating people simply because they are either sociologically not pulled into the conversation, or highly educated people are so narrow-minded because they don't think outside of their box. And so if you think of yourself as an organism, and we are all organisms, and you extend that thinking to the collection of us, joining together, we are a community, as you said. I found that very, very nice. We are a community, and we don't need to do everything ourselves, but we need to be able to share knowledge laterally, in a non-hierarchical manner, and really collectively move forward. And if we move the whole conversation into that area, we really change the way science is done, because in any invention is always reflected back to the needs of the whole group. And the whole group makes a decision, and it's not compartmentalized, hierarchically to those who are in power anyway. So that is something I would love to follow up with the whole group, and certainly with you, Alessandra. And that's just a comment. I have no question to you, because I know from your reaction that you exactly know what I'm talking about. So, and that also intrigued me when we spoke in Dublin. I noticed that this transdisciplinarity is at the core of moving forward. Mm-hmm. And if we think we only alone can move forward slowly, but if we join forces smartly, we can move forward much faster. And that's the point, where collective intelligence is something we need to really push and utilize. So we are coming to the end of the session, but maybe Jan has a question.
Yes. This talk, just to say frame the praise in a different way. This talk was exactly what I needed right now. Let me explain this, because just beginning of this month, I joined a 9 days workshop, really intense, with staying overnight and so on. It's an art science collaboration, and we discussed Haraway, but also Sylvia Winter, if you know her. Winter went one step further.
Mm-hmm. I don't know her. Please.
Yes, very similar to Haraway. She calls it not situatedness, but the positionality.
Mm-hmm. Yes.
And always risking replicator codes that manifest the color line and a division of people. And we were asked, after getting familiar with these texts, how does this manifest in your work, and what would be ways out? So I was really thinking about, because that's very present to me at the moment, is a project at Bonn University that they build robots for precision farming. So agricultural technology in combination with a research area that's called Future Rural Africa. So there are many pitfalls. Yeah? In the worst case, the researchers will say, let's show those Africans how to do it properly. Mm-hmm. That would be terrible if this is the case. Luckily, it's not. But there's very fine lines where a kind of colonial thinking manifests itself in these kind of projects. But this was very clear to me, how I can outline these mechanisms. And I was always thinking, because I still like to work with chemists, what is a chemical example for it? And because it's only 1 week, I couldn't come up with any, and I thought it's much more hidden in some way. Some are obvious, but I don't want to look at these. I want to look at these fine lines that have to do with the own work in the lab. And I think you gave so great examples where this is the case that we could use. So I'm not sure if you use them in your teaching, or if there's any, let's say, if you can recommend any good overview of really chemical cases that can illustrate very, very strongly to young chemists how even the most basic experimenting, let's say, for a master or PhD thesis can have these pitfalls that we want to point them at.
I resonate with many things that you said, and I would love to hear more about where this 9-day was and how it connected, because that's how I would like to, I'm self-training on this, and I think it's attracting enough interest that I'm having very useful connections with philosophers, and so. But for example, I heard about positionality, but not about winter. So maybe you have suggestions. Yes, there are examples. There are examples, and the question that we have, not to go specifically, I can say chlorodeacone, for example. Have you heard these examples about a banana bug, pesticide that was ruled improper to use by the FDA in the 70s, and French people from the Martinique bought all the excess and used it within their soil, and then France banned it, but they had an exception for Martinique, and now 40% of Martinique soil are completely polluted, and 90% of Martinique people are ill with cancers because of this. So we can make examples of these connections, but something that is maybe a little more connected to our job is about the criteria that allow us to consider a research excellent. These criteria, how they are embedded now, is among the ways of keeping in what is science and keeping out what is secular knowledge, what is not up to level. And it's ingrained. It's ingrained. If you need a machine that costs 1 million euros to do something that is considered indispensable, you're already making a decision. And some sciences need that. But if we were to allow among our midst science that are for surviving out of 5 degrees, then you would have to develop tools that could be made at 5 degrees. And using a 1 million machine would disqualify you as poor survivalist science. You would be very good, whatever science we're doing now, the hegemonic one. But if we're thinking about the science of decolonial science, producing knowledge on ancestral, producing papers on ancestral knowledge without having authors that are connected directly to this ancestral knowledge would be disqualifying. You're committing something that is not connected to your values. So we have to rethink the criteria, which is not, and that's something I would be really interested in working. If you like this idea of the situated chemistry, I had the chance of having Green Chemistry saying, we like what you're doing, but write a paper and we'll do a special issue. And now we're struggling. We're struggling because we don't know how to tell the reviewers that they have to develop other ways of evaluating.
Yeah.
If we're sincere about this opening and perspectives and things like this, we have to deconstruct also the way by which we're imposing the frontiers between who is in and who is out. And that's why also it's about epistemicide and how we have systemic discrimination. So I don't know if I'm answering what you say, Jan, and I would love to hear more about what you did for the 9 days, and maybe we can think and.
No, it's we have other occasions to discuss this. One thing is, I just posted a link to a text, which I have to admit, it is really difficult to read if you're not from that discipline, but it gets to a very important point in that she discusses later in the text, the IPCC, and how it kind of reinstantiates a certain mode of, man. He calls man too, like that's the homo economicus of the Western world, and imposing this image everywhere by saying this is an anthropogenic problem, and we have to find solutions with the same methods that caused the problem.
Absolutely.
And this is very interesting. Yeah.
That's what I'm trying. Anthropocene has been called Machocene, has been called Capitalocene, has been called octasionocene. There's a lot of ideas around this that if we don't go and that's why I've been expanding and expanding and expanding, because I realized that, for example, doing research on CO2, it's not enough. It's not enough. Right. You read some paper, it's not enough. So how can I articulate in a way that is scientific this necessity to make the connection? It's not a desire, it's a necessity to do it well. And if I'm a scientist, I have to do it in a scientific way. So anyway, so I agree with this and looking forward to continue the exchanges.
That's also why, if I may say that now, I'm also critical with AI as proposed solutions, or as Hartmut framed, can it help us? I would say it's another risk of re-manifesting or re-instantiating exactly this kind of positionality, saying we find a kind of techno-scientific, or in the worst case technocratic solution for a problem. And I fully agree with you, Alessandra, that if we want to have a proper discourse on that, we have to make it decolonial. We have to get people at the table that are currently not having access to it because of formalities like not having a university degree. So yeah, but I think what you have shown very nicely is, so what does it really mean for the way we frame our work, we plan a research project, we form a habit of open-mindedness towards that, because I think it is possible, and it is not a question we can delegate to some kind of politic frameworks, but there are connecting points in our day-to-day work.
Yeah, but I mean, the informatics gurus, I know I have some friends who are very excited about the possibilities, and they say, this will be paradise. From there on, we will leave everything to the algorithm, and we don't need to think. You know, more or less, to cut it short.
Can I contribute with a sentence which I heard recently? As long as we don't know what natural intelligence is, we should not talk about artificial intelligence.
Thank you very much. I thought about when you gave the lecture about CP Snow. He started this whole discussion off. I mean, this is something which, I mean, it's unbelievable, your contribution today. Thank you very much.
Thank you very much. It was very interesting.
Keep well.
Thank you.